Now we're going to look at the open-ended questions on this section 3 practice test. So we're going to start with number 16. In number 16, we have ourselves an equation with a fraction in it. And it just so happens that there's a variable in the denominator. So one of the best things that we can do when we have a situation like this is to just clear the fractions. In this case here, we're going to multiply by x. If we multiply by x, that's going to eliminate the fraction because, of course, the x and the x are going to cancel out when we multiply it by 81 over x. But we have to multiply x by every single term, so that means that we have to multiply x by x, that's the x squared. As we mentioned just a second ago, x times 81 over x is 81. And then on the right-hand side, we have to multiply by x also, so 18 times x is 18x. Now we have a quadratic. Our standard operating procedure when we have a quadratic is to move all the terms to the same side. So let's move everything to the left-hand side. That makes the equal 0 show up. Now, if it's factorable, which indeed it is, we can set each factor equal to 0 and find the value of x. In this case here, it's only one solution because both factors are the same. They'll give us the same result. X equals 9 is the one and only solution. If we move down and take a look at number 17, this question, as it's constructed by IES, is a little bit too much for the SAT. All right, there's a little bit too much work involved, but the individual pieces are still kind of like valid. The first thing that we need to do is we need to combine the x squared, sorry, not x squared, pi over 2 minus pi over 6 into a single value. So that's just a matter of finding a common denominator and simplifying the fraction that results. So 2 pi over 6 becomes pi over 3. Okay, so we know we're trying to find the value of cosine pi over 3. Where do we go from there? Well, pi over 3 is a measure of an angle, but it's in radians. Okay, so we have to convert into degrees, most likely, to understand what's going on. Now, some of you are going to have an advantage. You might have learned in class, how, that you have to memorize what cosine of certain angles and radians are equal to. So if you know that, then of course you could jump right to the final answer. Okay, but I'm going to assume that either you don't remember or you haven't learned it. There is a way to get further now using information that's given to us on the front page of the math section. All right, so on the front page, it tells us underneath all the pretty area and volume formulas that a circle is 360 degrees. It also tells us that a circle is 2 pi radians. So by knowing that, we can set up a proportion, or if you know another way of doing it, that's fine too. Some of you might know about like multiplying by pi over 180 or 180 over pi to convert from degrees to radians and radians to degrees. But I like proportions, so I might do something like this. Pi over 3 is out of 2 pi radians, so we want to find out what x is out of 360 degrees. Um, if we cross multiply this proportion and solve for x, we get that x is equal to 60 degrees. Okay. Now, how do we find the cosine of an angle 60 degrees? Again, some of you might have learned this, right? Like you memorized what cosine of 60 degrees is in school. But if you haven't, we can still get the right answer. Right on the front page again, printed on the top right-hand corner are two special right triangles. One of those special right triangles is a 30, 60, 90 triangle. So if we take our information that we got, we want cosine of 60 degrees, and use it in that right triangle, and apply SOHCAHTOA, right? Remember, so sine is equal to opposite over hypotenuse, ka, cosine is equal to adjacent over hypotenuse, and TOA, tangent is equal to opposite over adjacent. We can find out what the cosine of 60 degrees is. So if we line up the triangle, right, like this, and put the 60-degree angle there, the adjacent side would be x, and the hypotenuse would be 2x. So that tells us that cosine of 60 degrees would be x over 2x. And even though we don't have numerical values, guess what? The x's will cancel out and give us the numerical value that we can then bubble in. So let me just shift it down a little bit. Now, if you are looking for like every single advantage that you could have on the SAT, it might be worth memorizing the cosine and sine values for these angles in the first quadrant, right? So 0, 30, 45, 60, 90 degrees. Um, there is a neat little system to help you memorize that. Generally speaking, signs go up, right? So you can kind of see here 0, 1, 2, 3, 4. And that's a way to kind of like just know what the pattern is. And of course, if you have the square root of 1 over 2, that simplifies to 1/2. If you have the square root of 4 over 2, that simplifies to 1. So um, this is just to help to kind of like help you remember, hey, signs go up, 0, 1, 2, 3, 4. Cosine therefore goes down, 4, 3, 2, 1, 0. Okay, and built into this table is also this other thing that's really useful, which is that when two angles are complementary, like 30 degrees and 60 degrees, then the sine of one angle is equal to cosine of its complement. So we can see from the table here, for example, the sine of 30 degrees is 1/2, and that's equal to cosine of 60 degrees, which we just solved for, that's equal to 1/2 as well. So again, if you're looking for a little bit of an advantage, it rarely pops up, okay, this little disadvantage, but if you're looking for every single advantage, trying to get that 800 on the math, you might just want to review the trig table as I've established it here. Okay, so number 18 is a polynomial division problem. So just as a little note, on the SAT, they'll very rarely use the division symbol or like a long division hat to denote that they want you to do polynomial division. They'll print it as a fraction. This particular problem is too much for the SAT, right? They've never given a polynomial like this on top that you're dividing. So it's a little bit unrealistic. Um, However, what we're talking about here will kind of apply. If you see a fraction like that and you can't factor and then simplify the fraction, then your only option is to do division. There is a method, of course, that called long division, which will get us the answer. But that generally takes too much time and effort. So if you know about synthetic division, it's a much better way to go. Now, just FYI, if you do need a review of long division or synthetic division, a little more careful, you can go to YouTube and just like type in a search for polynomial long division or synthetic division, and you'll come up with plenty of videos where you get walk through a practice problem or two. So in this case here, I'm just going to do it kind of fast forward. Since we're dividing by x plus 7, that means that the x value that we're actually working with is -7. So we put that over here on the top left. Then we list out all of the coefficients from that polynomial. So it's 1x to the fourth, 8x cubed, 3x squared, minus 29x, and then -7. That's those values listed out left to right. Then we copy down the first number, and then we go into this pattern of just multiplying and adding. So we multiply 1 and -7, and then we add down the column, and we get 1. 1 and -7, we get 3 plus -7, -4. -4 times -7, that's positive 28. -29 and positive 28 is -1. -1 times -7 is positive 7. -7 plus positive 7 is 0. So the last number in that last column is always the remainder. We know enough then, right, to solve the answer, get the answer that b is equal to 0 then. But how do we kind of summarize it? The 1, 1, -4, -1, that would be the coefficients of our quotient, our answer that we got from division. So you can see here, if we had to list out the results of our division, we'd say this fraction or this division is equal to x cubed plus x squared minus 4x minus 1 plus a fraction where the remainder goes on top and what we divided by is on the bottom of the fraction. Okay. Let's move on and do number 19. Okay, so this one is uh, basically a substitution exercise in the very beginning. We have to know that if we know that f of x is equal to this thing over here, whatever we get inside the parenthesis represents what we're going to substitute. So even though it has an x in it, we are going to substitute x plus 2 in place of every single x. Well, it turns out there's only one x that we get in the definition, right? So f of x plus 2 ends up being this thing over here, All right, so notice I've replaced the x with x plus 2, and I put it inside parentheses to make it a little bit more obvious what I did. Therefore, if we're being asked to then find what g of negative 5 is, well, the x value that we're going to substitute in is in the parentheses. So that means we're going to place negative 5 everywhere that we see an x. So that means that we insert the negative 5 over here. And now it's just a matter of simplifying, um, using what we know about order of operations and things like that. So inside the parentheses, we're going to end up with a negative 1. If we cube that and then distribute and add the 1, we get our final answer of 3. Okay, now we're down to the last one. Let's see this problem. All right, this is a system of equations. All right, we've seen a couple questions with 2 equations already. This one obviously is a little bit more scary. We got a circle and a line. But it's not that scary actually if you know this fact. Intersection points on a graph are the same as solutions that we solve with algebra. So if we look at this graph, we see 2 intersection points. That means that there are 2 possible solutions then, okay? And what do we do when we have something weird, like it's not 2 lines, it's a circle and a line in this case, or maybe a parabola and a line? It's going to be substitution, all right? Solved by substitution. In this case here, we can plug in what y is equal to, 2x minus 1, into that other equation, which is the circle equation. Now, it might look scary, but guess what? Things clean up very nicely. All right, so if we FOIL 2x minus 1, we get 4x squared minus 4x plus 1. We'll end up with just 2 terms. So this is a binomial then. How do we solve this? Well, it turns out that this one is just a factoring thing, right? If we find the common factor, x, and factor it out, we get this factoring over here. When we get an x factored out like that, that means that one of the solutions is x equals 0. And then, of course, the other one, if we set 5x minus 4 equals 0, we get x equals 4/5. Looking at the graph, we don't want this intersection point, x value. We want the other one on the right-hand side, the top right-hand corner. So that means that, of course, our answer is x equals 4/5. Okay, so that's it.